I'm happy to introduce this conference and to start with some reflections about research policy in connection with the issues of mapping cultural heritage. Open science, as you know, is now an established principle supported by all research actors from national and international level. The French School of Athens has been an actor of open access for almost 20 years when we put 500 volumes of our publications online in 2003 on the portal named The EFA, as you see it on this screen. And since then, the French School has been developing several digital tools, setting up best practices and a range of services to strengthen open access in our research communities. All these actions are now part of a real institutional policy, which we formalized last year with the creation of a steering committee and with the drafting of a charter for open science, which is available on our website. And you can see here a picture from this description of the chart and the open access policy of the school, which is accessible on the website. This policy considers the life cycle of the data produced during the research activities of our teams. And this research activity is dealing, of course, with research on the field. So we consider this life cycle of the data from the organization of a program to the publication of its results and their subsequent reuse by researchers and or eventually by a broader audience. As you can see on this slide, you have the several steps that we have planified for the life cycle of the data that we produced and that we're trying to provide in open access. It is still a work in progress, but at each step of this cycle, we intend to provide researchers with guidance, with methods and application in order to have their production online with the FAIR principles. I mean, findable, accessible, and interoperable and reusable data. So we intend to have their production online with those FAIR principles and in compliance with the legislation in force concerning open access. Each department of the French School has actively contributed to this purpose, especially the IT department, which is developing interoperable applications within the schools and which is also connecting them with national and international portals. You can see on this slide several of them. For instance, the Bulletin archéologique des écoles françaises à l'étranger, which is the publication for the report of the activities, not only of the French school, but also of the network of the French schools abroad, is an online publication, which is at the French School of Athens connected with the database Archimage, which is a repository and data set for archives, which can also be connected to several GIS that we have developed at the French school and on the sites the French school is working on, and also is also connected to the Chronique des Fouilles en ligne, which is well known, that we are publishing since decades with the British School at Athens. And so on. And this system of connections offers us also the capacity to be visible on external levels and networks like Ariadne Plus or Europeana and such other European and international systems. So as you can see, it is a chain with concatenations inside the school, but also outside the school. The scope is to have all of these tools and repositories connected together. And in a while, Lionel Fadin, who is in charge of the topographic service of the school, will develop the demonstration of those connections starting from our GIS. So such a system is protective for research and for scholars because it creates a safe environment to use and to reuse legally the results of any research. It is also convenient for the research user because it is anyway easier and better shared to have access to the archives in that way than in the former one. Although the former one also works, but we prefer, I think, to share now research in the actual one. But however, how far is open access better for cultural heritage? That's a question, an issue that we have also to raise. And how can we reach an efficient use of open access for this purpose? I would like to address very briefly a few issues about this experience. Once you publish in open access a GIS from a site with full information about the archaeological material through all the required connections to data sets, many people would report that open access offers a detailed information for looting and trafficking artifacts. So once we do the mapping of cultural heritage on a site, should we better keep our GIS on restricted access? Other options would emphasize, at the contrary, that open access provides better conditions for the monitoring of an archaeological site, since it creates a well-documented environment and makes people aware of the public value of the archaeological heritage as a common property. And this is the option chosen by the French school, but it requires a lot of presentation work so that a broader audience can really use a GIS as a tool for protecting cultural heritage. So it is a challenge that we need to address and that we need to face in this optic. The second important issue that we have to bear in mind about the use of open access for cultural heritage is the connection with the field. Open access and fair data create an efficient system for data-based research, but we should not blind ourselves to the fact that this technical support can deeply change our approach to archaeological material. That we have connected data does not always mean that we have out-of-site data. Such challenging projects at the creation of a European science cloud can be fascinating, but this goal should not prevent us from coming back and repeatedly to the field and to primary sources. So this is why a research institution such as the French School of Athens can bring, I think, to these issues related to open access, a singular reflection and help to move forward from incantatory mode to achievements. And I would like now to let the floor to Lionel to present you some of these achievements in the framework of the work of the French School on GIS.
Thank you, Véronique. It was in 2006, during the creation of the Atlas of Delos, that we successfully tested the technical feasibility of transferring the graphic data from the Atlas to the GIS medium. From 2012 to 2018, several geomatician trainings with the support from EFA services set the foundation of the current version of our WebGIS. In 2018, an overhaul of the interface components made it possible to maintain access to data through a renewed interface. The main idea behind the creation of this WebGIS project was to give researchers easy access to geographic data. Indeed, the constraints of updating software, learning and mastering these tools often represents an insurmountable barrier for the majority of the researchers. A tool such as Google Map, used by majority of people, seemed close to what we were looking to develop. Visual access to correctly georeferenced data, simple navigation, printing, and research tool. However, we did not have the human and financial strength of company like Google. Being able to provide an accurate, precise, homogeneous background map at the scale of a site was a strong motivation. But the system also had to make it possible to accommodate the data produced by researchers in different forms. The system has to interoperate with other EFA resources. Today I will present the different stage of the work that led us to the online publication of our WebGIS. I will quickly explain the step of data acquisition, formatting. Then I will go into the details of the question of benefits of our interface, and we will discuss the tools this version provides. Finally, we will look at the work that remains to be done to put WebGIS at the center of the digital tools developed by EFA. The first important phase is based on acquisition of field data. It makes it possible to verify the accuracy and precision on the data while offering a first interpretation of the reading of the archaeological remains. Here is the concrete operating chain that we follow. Assessment of existing old plans to determine what can we be used as base plan for the field sketch. Creating sketch by applying a graphic charter. Topographic survey at the scale of 1 to 200 of the archaeological remains when necessary, creating orthophoto, and drawing map into AutoCAD map 3D, return to the field to check the accuracy of the plan. At this point, as the data have been checked and validated, they can be formatted. They can be we can convert AutoCAD layers to shape format layers, convert attribute table into format readable by QGIS, transfer data to PostgreSQL. In this way, GeoServer allows data to be read to PostgreSQL and display in the web browser interface. The main point was to create a geodata repository to store all the data created at this point, but to be able to reuse it after the project and many years after. Now the EFA have a system to store all kinds of geographic objects without the limitation of a version of the software product. We have chosen to use an object relation database at the global repository and to store the data as pure geometric object. For that purpose, we are using PostgreSQL with the GIS extension that is totally open source. The direct benefits are multiple. Different access of privilege for the user depending on their status. Different access to the data depending on their researches. Compatibility with the major GIS software product, easy to back up and maintain, possibility to access the information everywhere. The only requirement is an internet connection. The database is hosted on a supercomputer that decreases the rendering time for operation. All the data are stored centrally. The point here is to offer the community of researchers an easy GIS tool. The GIS expert will still use their advanced GIS software, while researchers can directly use the data created and present in repository using the WebGIS. The challenge is to propose an easy and intuitive tool having the same functionality to explore and research geographic and thematic information as most professional GIS software product. Furthermore, a WebGIS will not require any installation, license, computer powerful, or large internet connection, and it will be multi-platform. The only requirement will be to have a modern web browser installed on the device used, like Firefox, Safari, Chrome, Microsoft Edge. The WebGIS will also use the data in the global repository to have the latest update the data. And finally, we will add some feature to modify and create GIS data to those research who will have the privilege for that by a simple way. Benefits of this architecture for the user are multiple. No software installation required. Device independent, operating system independent, no updates for the clients, data control and privilege managed by EFA, low computer power, use the WebGIS everywhere, only an internet connection is required. One of the main benefits is to adapt the WebGIS for each project or depending of the thematic study at this point, considering that we can reuse any functionality developed for one project to another, each project enhances the whole WebGIS. EFA WebGIS have the same functionality as other projects of the same type. When opening the WebGIS in the internet browser, the main part is the map and its zoom adjustment, like plus, minus, and the scroll bar. The lower banner provide us with the coordinate of the cursor moving on the map in 3 different coordinates: Greek system, WGS 84, and local system. At the top and on the left, the active layer management window allows you to move the publish layer in the map windows by drag and drop. This is also where you can remove the layer from the map or even center the map on the layer or even play on the transparency of the layer. At the bottom and on the left, the layer section window allows you to make the layer visible or invisible. The name of the visible layer is displayed in bold. In general, at least 4 different layer categories are available. The background map, here you can see the outline of Delos Island on the blue background. But you can activate the orthophoto plan or the orthophoto plan provided by the Greek cadastre or any layer provided by companies such as Esri, Google, or Bing. The thematic layer aggregates into a large family such as ancient construction, level curves, toponyms, or even floor surface type. The Chronique de Fouille, which gather the information available on the EFA Chronique de Fouille site, and all master plan or raster plans which often served as the basis for dragging up sketch during field survey. The retractable right window using the middle button at the top right allow you to display the graphic legend. The 2 other buttons on the right on the top banner give us access to language choice and credits. In the credit windows, you will be able to access the credit, but also to the user manual of WebGIS and the URL from connecting to WMS field for AutoCAD, ArcGIS, and QGIS software. The top banner is made up of buttons containing the classic tools found in web mapping, namely measurement tool, where you can find azimuth, distance, and area. Search tool for building lists in the site guide, which refer us to the record of this book. A click carry tool. Printing tool allowing output to image format, or in PDF or in GeoTIFF in different EPHG. A full screen tool, a bookmark tool, and to add a display bookmark. zoom modification tool with a predefined scale. Layer carry tool. After selecting a layer from the list, you can select graphically using a point, circle, or a polygon. Finally, from the 3D button located on the top left on the map of the map windows, it is possible to switch to 3D mode. The small plane button allows an automatic flight over the terrain. In the main windows, you can use the right mouse click to zoom in or zoom out, left click to move the document, and holding down the wheel rotates the image. The arrow button allows the reorientation on the map with north up. This is a visualization of the island orthophoto plan placed on the digital terrain model resulting from the contour lines. Not only the WebGIS provide the secure, reliable, complete, precise, and attractive background map, but they also communicate with the other digital tools set up at the EFA. For example, excavation chronicle refer to WebGIS, and WebGIS can display a link to the chronicle. The most recent development project, and which concerns a large part of the service in the creation polygons linked to an authority list provided by researchers. These links will allow you to navigate from one search tool to another. The WebGIS will then be the cartographic reference for all these data. The school current research has, of course, been brought into line, and we strive to ensure that the new graphic or attribute data is compatible with the WebGIS data. This research is based on a used WebGIS data. The result of this work, currently in progress, will then be added to the public version. For example, the urban morphology study of Delos use existing data, and after publication, new data will complement them. Similarly, links to Archimage are currently being developed. For example, we can visualize 3D models stored in Archimage in the WebGIS 3D environment. This kind of project can only be carried out over the long term, which only a sustainable institution like the EFA can support financially, scientifically, and in terms of human resources. And I wanted to thank here the various EFA management teams who have supported this project for many years now. I wanted to highlight the very important contribution of Brio Guillaume, who joined the team in September 2021, and would devote all this time to this development of this project. These projects are long and time-consuming, but once they are set up, we realize all the potential that can be exploited. EFA now provide researcher and public with free, reliable, and accurate sources. The next upload will concern the Korça region in Albania, where archaeological work has been carried out in the recent year. The Delphi and Malia site project are currently under construction. Fieldwork fill the database every year, and we hope in a few years to be able to provide the public and researcher with the same quality of work as one the other site already done online. Thank you for your attention.